So, hello everybody. I think this is going to be the start of my YouTube channel. Now, for those of you who don't know, some people who can be watching this on YouTube, I presume, I'm going to be giving you a bit of the context why I'm starting this. So, I started to post some explanation videos regarding some questions of physics and mathematics on Reddit, not on YouTube, because I think the communities they were already well established, so we have a set audience from the get go. And some people there asked me to post this stuff on YouTube, so I'm just going to be doing that. And also another thing, I like to create physics and mathematics questions myself. Now, I won't really be always discussing, I won't really be always discussing those questions on YouTube that I've created myself. Maybe some other questions, the good questions that I find from here and there. But this is one kinematics question that I created myself a while back, and now I'm going to be discussing its solution in this video. And I think that's all. So let's just directly jump into it. So, the question says, a particle of mass 1 kg. So what this basically means is whatever the force is being applied is going to be directly equal to the acceleration. That's all. Is projected from the origin with initial speed v naught. Right. So it is the speed, not the velocity vector, obviously, because there is no direction given. Now, the components of its initial velocity satisfy that mod vx equals to mod vy. Right, so this means that the initial speed along the x-axis is going to be the same as the initial speed along the y-axis, and the gravity acts in the minus y direction with magnitude g greater than 0. So basically it's this, that the gravity is going to be acting downward along the vector minus y cap, right? Simple as that. Now, a wind exerts a position dependent force along the z-axis, which is F wind equals to Cx cap, where C is greater than 0. And we are supposed to determine the necessary relation between R0, G, C and V0 for the particle to pass through the point R0, 0, 0 at some time t greater than 0. Right, so how do we approach this problem? Now the thing is, we can just find out the V0, right? So we can just find out V0 or V0 square in terms of R0, G and C, and that's going to be a valid answer. Now, for R0 to be here, right? Now I think I have not written out some assumptions properly that the x cap, the dx is also going to be along the positive x-axis, and the vy is also going to be along the positive y-axis, right? Because I was this is one of the first questions I created, so my phrasing wasn't as good back then, right? So the basic diagram is going to be this, that R0 is here, and the particle is being thrown with velocity vector v0 as shown, and there is going to be a wind force vector like this. Now the thing here, now first of all, the assumptions. I'm going to be letting Vx by V0 equals to Vy by V0, obviously, because this is given here, that Vx equals to Vy, that is given here, so I can do that, is going to be equal to alpha, and Vz by V0 is going to be equal to beta. Why I am doing this is because I can write down the velocity vector like this. That is the thing. Nothing has, also in the question, nothing has been said about Vz, given the fact that, so I think some people would see the question and directly assume that Vz is going to be 0, but no, that is not the case, because the moment Vz is going to be 0, what that means is that the initial speed along the z-axis is going to be 0, but force is being applied along the z-axis, right? And as force is being applied along the z-axis, the particle will move away from the line z equals to 0, and it will never hit the projected point. So Vz has to be non-zero, and it is implied in the conditions. Rather, I'm going to have to, now the thing here is the force is along the positive z-axis, so I'm going to have to initially throw the particle towards the negative z-axis, right? So the speed along the z-axis is going to be along the negative z-axis. so as to it counteracts whatever is going to be the acceleration or the work done on it along the positive z axis, right? I think you should understand what I'm trying to say here. So I can write down the initial velocity vector as v naught vector equals to v naught times alpha times x cap plus alpha times y cap plus beta times z cap, right? Now what I can do here is that mod v naught is going to be equal to v naught, and this gives me that 2 alpha square plus beta square equals to 1, and this is going to be a very necessary relation for me to solve the question, right? So at any point x comma y comma z, this is going to be my acceleration for the particle, which is also going to be the force, right? So this is going to be the acceleration, that is going to be minus g times y cap plus cx times z cap, right? Now notice that there is zero acceleration. The motion along the x-axis is not accelerated at all. Okay, now using this, what I can say is it is a uniform motion in straight line when I am only considering it along the x-axis, right? So the x coordinate can easily be given by alpha times v naught times t, and what I'm going to be doing is I'm going to be putting that into my general acceleration vector, and then after I do that, what I have is acceleration vector is going to be minus g times y cap plus alpha times c times v naught times t z cap, right? Now acceleration is going to be equals to dv vector by dt, and I'm going to be taking that dt here, right, and then integrating. That is what I'm doing, so that I can find out what is going to be my v vector at any time t. That is what I'm trying to do here. So this is what I do here, dv vector from the initial velocity vector to the velocity vector at any general time t, right? So when I integrate it, what I'm going to be getting is that v vector minus v naught vector, as you can see, is written out here. I think the integration is very basic, so I don't really need to explain that part, right? And then again, just using that v vector is going to be equals to dr vector by dt, and then taking this here such that, and then integrating again to find the position vector at any general time. And once I do that, this is my position vector as I've written here, that is here, right? Now what is given here is that at time t is equals to capital T. At time t is equals to capital T, the particle passes through the point r0, 0, right? So what that means is that the position vector at time t is equals to capital T is going to be r0, 0, 0. Obviously that means the x coordinate at time t is equals to capital T is going to be r0, and the moment I put that into my position vector as a function of time, what I can say is alpha times v naught times t is going to be my r0, and I can say that my capital T is going to be r0 by alpha times v naught, and my y coordinate at that time is going to be 0, and so will be my z coordinate at that time, right? And the moment I use that for my y coordinate, what I can say is that capital T is going to be equals to 2 times alpha times v naught divided by g, right? And now because both of them represent capital T, they are equal with each other, and once I do that, r0 by alpha times v naught is going to be 2 times alpha times v naught by g. What I will be getting is alpha square is going to be r0 times g divided by 2 times v naught square, right? Now the thing here is I'm only concerned with alpha square because this is what I need here, right? So I'm pretty good there. I don't really need to care about the plus minus sign here, right? And now the z condition is going to be helping me with beta, right? So beta comes out to be this minus alpha times c t square by 6, right? And now I've written that exact thing here, but what I've just done is I've written t square using this equation, and it comes out to be this as I've written here, and then I square it up because again, what do I need? I need beta square, so I square it up here, and the moment I square it up, I put in the value of alpha square from here, and what I'll be getting is beta square is going to be c square times r naught cube divided by 18g times v naught square. Right, now simple, I've got alpha square and I've got beta square, and I can just plug it in my equation that 2 alpha square plus beta square is going to be equal to 1, and the moment I do that, the necessary relation just simply pops out, and any relation that is equivalent to this relation will be a valid answer. So I hope you like this video. I hope you understand the question, and I hope I will be making another video. Well, that's a bit weird way to end the video, but whatever.